Hey guys, here is a short video that I need you to take some notes on before you get started on your cosine curves today. I will be checking your notebooks on Monday to make sure you have this, okay? Before we get started, I want you to make sure that your calculator is in degree modes. So remember, we press the mode button, and then here where it says radian and degree, we want degree to be highlighted so that we are in degree mode for today. All right, so the first thing that we're going to look at is a unit circle here with a degree of 34. So often I'll be asking for the exact coordinates of a point on our unit circle, okay? But we can do that by creating a triangle here, okay? Where x and then y creates our ordered pair. So we already know that our y value is our height, and height comes from using sine, okay, because that is our opposite over hypotenuse. So we can simply take our calculator and type in sine of 34, and we'll do 0.56 here. All right, so if we want to find cosine, or our adjacent side here, we can use the Pythagorean theorem. So if we look here, we know that C is 1 because that's our unit circle. B is that 0.56, and we don't know what A is yet. So to do the Pythagorean theorem, I would do A squared plus B squared equals C squared. C squared, that would be 1. We don't know A squared. Plus 0.56 squared here. So 0.56 squared is 0.31. 1 squared is 1. I can subtract. And I get a squared equals 0.69. I can do the square root. And I get a equals 0.83. So back up here, that means this distance here is 0.83. So my ordered pair then would be 0.83, 0.56. And we can do a double check here using our calculator. If I hit cosine 34, sure enough, I get 0.829, which rounds to 0.823. So this being said, all right, we can take a look at a general unit circle, which I have here, okay? So something to keep in mind, remember sine gives us our height or our y coordinate. Cosine gives us our base or our x coordinate. You might see this as vertical distance and this as horizontal distance, which again, our horizontal distance to that point, and then our vertical distance to that point, okay? So in general, we can now say that if I want to find the ordered pair of theta, I can simply do cosine to get my x, so cosine of theta, and sine of theta to find my y. So that will always be our general formula. So if I said, okay, I want the exact coordinate for 127 degrees, I could simply come over here. 127 would be over here. And I could do cosine of 127, sine of 127. And then I can put that in my calculator. And I get negative 0.6, comma 0.8, and that would be my ordered pair, which makes sense because I'm going to the left, which would give me a negative x, and up, which gives me a positive y. All right, so let's take a look at what this is going to be on our cosine worksheet, okay? So a couple of things to pay attention to. We are going to start by labeling our degrees like we did before. Here we're at 0. This is going to go up to 90 degrees here, 180 over here, 270 here. So something that I want to point out that is different than sine. So with sine at 0, we had a height of 0, right? But here we have a width. So my width in this case for 0 is actually going to be 1. So the ordered pair here would be 0, 1. Excuse me, I'm going to flip those because I'm going to put the, since our horizontal distances are x, I'm going to rate these like this. So it would be 1, 0. So when I'm starting my cosine graph, I'm actually going to be starting up at here at 1 instead of at 0 where we've started before, okay? But then when I get to 90 up here, there's no width. So at this point here, my width is 0. So this would be 0, 90. So then when I'm over here at 90, this is where I'm crossing versus on sine where we started at 0 and then we were up here. This one starts and goes down. And you'll see that shape as you start to plot your points. So you're going to go all the way around and make your degrees. And then again, we're going to find our congruent triangles. So I've got these, which you'll see are your same triangles from earlier this week. Okay, because these all share the same width here. Same width. Okay, so if we want to know what the base is for 15, we said we can do cosine of 15. And I get 0.966. So we'll say 0.966 here is my width. So if I go to the left now, this is where our width will be negative instead of going down. So this is negative 0.966 because our x values, when we go to the left, it goes negative, where before down was negative. So over here, we still have a positive 0.966. And then over here, we would have a negative 0.966 because we're going to the left. So I know because, again, these are all reference angles that they will have the same height. So for the next one, I'll do 30 and find all of its reference angles. Whatever the height is here, I can use my symmetry and what I know about my different quadrants to help me figure that out, okay? So below in your table, you're going to have the same information as you did on the other side. Reference angles are found the exact same way, okay? And then you'll be able to graph using these ordered pairs. So for example, here I'm going to have 15 and then 0.966 is the width. So it'd be 0 and then 0.966. We're up here. Okay. Now, I want to change this graph here. This shouldn't say height. Change that to say base or width. So we'll say base for that. Okay. So we know now with cosine, we're talking in terms of our base. So you're going to repeat this process till you have all of the degrees, all of your triangles color-coded, you have all of your base widths, and then you have them plotted on here as well. Okay. On the next couple of slides, you'll see how we can use our special triangles or special right triangles to find exact bases for 30, 45, and 60, just like we did with the heights on sine. And I'll be checking this and your sine curve and worksheet on Monday. Have a good rest of your day, guys.